Troubleshooting problems in a Linux system. There isn't a system administrator out there who hasn't spent some time troubleshooting unforeseen problems. It takes a detective's mindset to narrow down the possible causes, deduce explanations, and then develop steps to remedy the problem. In such a process, there's no substitute for experience. And in this nugget, I'm going to try and give you as much practical troubleshooting experience as I can. So let's get started. There's different types of problems that you can run into in a Linux system. I've listed some here, and let's talk about each of these briefly, and then we'll talk about them in more detail when we go out to the Linux screen, and I'll show you examples of some of these and how to fix them. Okay, the first type of problem I have here is hardware problem. Now this is some, physical problem in your system, like some wire's broken, or it's unplugged, or you dropped your zip disk the other day and now it doesn't work anymore. Okay, and the way that you fix hardware problems is you fix that thing that's physically broken, or you plug the wire in, or whatever's wrong, And that zip disk that you dropped, maybe you're gonna have to buy a new zip disk to fix that problem. And then there's operating system problems or kernel problems. And these are not very common in the stable kernel releases. Remember that kernels are denoted by three numbers, and we'll call it x.y.z. Okay, that middle number, if that's an even number like 0 or 2 or 4, okay, those numbers represent stable releases and they've been really well tested, and it's rare that in those releases that you're going to run into kernel problems. Okay, if you've got some odd numbered kernel, some unstable kernel, why do you have that? Well, maybe you've got that because it was the only release that had a driver for this new piece of hardware that you got. Okay, so great, you can run that new piece of hardware, but you might get some the drawbacks to that, or you might get some issues with the kernel bugs. All right, so we'll talk about these briefly and sort of show you how to fix one if you ran into some kernel bug. You can download patches and recompile your kernel and stuff like that. We won't go into great detail about these. My suggestion is stick to the even, stable releases if you're an inexperienced user. And then there's application software problems. These types of problems, they're very close to the user's experience, so the user might report these fairly often. They could range from, some system setting has changed so the software isn't working, or, some flag in the software is broken, or it's not set incorrectly so the software seems broken. There's configuration problems. These could be system-wide configuration problems or user-specific configuration problems. And you would change the configuration files in etc for the system-wide ones, and you'd change the .dot files in the user's home directory for the user-specific configuration files. And then there's user problems, meaning some user account problem, like the user can't log in, or the user logs in but can't go into some directory that they think they should be able to go into. And these three types of problems here, software, configuration, and user problems, are very tightly related. Some configuration setting that you made could make software not work anymore. It could give some users might have different experiences than they had before, and so you have to make sure when you're troubleshooting these that you're thinking about all three at once and how one change in one setting is affecting other programs and other experiences in the system. Now, no matter what type of problem you have here, I formulated a plan of attack for you to take to try and solve it. So the first thing that you should do is observe the problem firsthand. This is really important, especially when people come to you and report this problem. Don't just take it, that's a broken, and then you try and start fixing things. Observe that problem firsthand. Get them to recreate that problem for you. Or if you observe the problem yourself, recreate the problem yourself. Make sure that you can have this problem be reproducible. So if you can recreate this problem over and over and over again, then you're going to be a long way towards formulating a guess as to the cause of the problem. All right? And I'm going to try and give you some tools here to help you formulate guesses as to what the cause of the problem is. And then attempt to fix the problem and keep good records here. So when you attempt to fix the problem, my next step says go back to step 1 until it's fixed. So you attempt to fix it and you go to recreate it again, you go to reproduce it, and it's still there. All right? Well, maybe what you fixed is essential to having it solved, but maybe there's something else along the way. Or maybe what you did was superfluous and it's going to mess something else up. All right? So you have to be really careful here, keep good records, and then when you're all done, you're going to be sure that the changes you made fixed the problem that you want it solved and it didn't affect anything else in the system. All right? So this is like a little circular diagram here. We're going to observe, formulate a guess, fix it, and go back and see if we can reproduce it again, and so on. I've listed out here some preventative measures that you should take just so that you have to troubleshoot less often. First, buy supported hardware. Stay away from the brand new hardware with the experimental device drivers, that kind of stuff. If you stick to the supported hardware, you're just going to have less problems because people out there have tested this extensively, lots of people are using the hardware, and you're just much less likely to run into problems with that. For the same sort of reason, stay away from untested software or beta versions of software. Okay, like it says, untested software. It hasn't been tested by the community. It hasn't really been, all the kinks haven't been worked out yet. So just stay away from that. If you absolutely positively have to have this piece of untested software or this brand new hardware, then go ahead and use it. Use the experimental device drivers or whatever you need to get it working. But be aware that if some problem creeps up that you can't really track down the source of, it might be in this unsupported hardware, this beta software, and you should uninstall this stuff and try it out again, try your system out again and see if the problem persists. And the chances are that the unsupported hardware, the untested software is causing those problems that you can't track down the source of. And lastly here I wrote, don't overclock your processor. Maybe you don't know what this means. Let me explain. When you buy your processor from Pentium or AMD or whoever you bought your processor from, that processor has an advertised speed like 500 megahertz. There's switches typically or jumpers on motherboards so that you can run that processor to faster speed. Okay, it's a faster clock rate is what it's called. And that clock rate that's been advertised by Pentium, the reason they advertised it or sold you that as a 500 megahertz chip is not because they're trying to scam you and it's really a 666 megahertz chip. It's really because they've determined that that's the right speed for that processor so that it can run for long periods of time. All right? When you run that processor at a faster speed, more heat is generated in the processor. The processor might not be able to dissipate that heat quickly enough, and then things are going to start to fail and break down. Okay? So don't overclock your processor because that's just, it's just a problem waiting to happen when you do that. One of the first things you want to do when you discover a problem in your system or somebody reports a problem to you is you want to narrow down the possible causes of that problem. And one of your biggest allies in narrowing down the causes to some problem are the system log files. And so if you go to the var log directory and do an ls there, you'll see a whole bunch of log files in here. Now, each of these files basically holds information on some different aspect of the system. Okay, like the boot log file holds information like boot messages. The mail log file holds information about the mail utility and so on. Okay? Now, to keep track of what each of these files holds, you can go to the etc directory and look at the syslog.conf file. Syslog.conf will hold and tell you which of these log files holds which types of error messages. All right, so let's look at this file. Basically, this file has two columns. Okay, the left column says, what type of facility or what's the service that is generating the error message, and then what log file should that error message go to. All right, so let's look at this one. Mail.star goes to var log mail log. What does mail.star mean? Well, the left-hand side here is really two pieces. The first part is the facility, and the second part is the level or the priority of the message. How important or how severe of an error message happened, and then this is saying any type of mail error message that happens should go to var log mail log. Okay? Now you could, if you wanted to, distinguish these and say put like unimportant mail messages into one place and put very critical important ones somewhere else. All right, you could do that, and let me just show you how you would do that if we quit out of here and look at the man page on syslog.conf. In that man page, here's the listings of the priorities. Okay, so the priority, meaning like the importance of the message, is classified by these keywords. There's debug, there's info, there's notice, there's warning. These are kind of like the low level, not very important messages, kind of like low on the totem pole in terms of importance. And then there's like critical, alert, emergency. These are absolutely important messages, and these things should, be fixed immediately. Whereas these things can kind of linger on. These messages are telling you something, but the critical operation of the system is not in jeopardy. Whereas with like emergency messages, you should be fixing these things immediately. All right. Now, so you can use those keywords to like funnel your messages off to different files. So if we quit again, like I said, you could have like mail.debug here go somewhere, and then mail.emergency go somewhere else. You want to make sure that you you use all the different classifications. You don't want like mail.info notices to slip through the cracks. So make sure that all the different levels of messages are going somewhere. Okay. Now. Up here, you can see there's a designation for the var log messages file. There's a classification over here that says star.info. So any type of info message is going to var log messages. And this is also saying that no mail messages should go there, no auth priv messages should go there, and no cron messages should go there. Auth priv messages, they're all going to var log secure. These messages, my var log secure file is empty actually. Auth priv messages are really something to do with, authentication, like somebody logging into the system or trying to get access to the super user account, that kind of stuff, user authentication. But it's private authentication, meaning that if I saw the message, there's some sensitive data even in the error message, and they should go somewhere like var log secure, somewhere special. Like I said, my var log secure file is empty, maybe yours is too. These messages are not used very often, okay? But mail messages certainly are, cron messages certainly are, things like that. Two last things. One last thing here is the star.emergency. All right. What that means is that any type of emergency message goes to star. All right. What star means here is everybody who's logged on the system is going to get an example of that error message. It's going to get a warning of that error message popping up on their screen. Like if one happened right now, it would pop up on my screen right here. Okay, these are not very common, and the reason we just have it as star here is so that everybody on the system sees it, somebody can report it to the system administrator immediately, and we can start to fix it immediately because something is in real danger here on the system. We could, something really important is happening and we should fix it immediately. Okay, one last thing I want to talk about is, look at this like var log messages file, for instance. All right. So say somebody breaks onto your system. They break into some regular user account like Alice, and then they start trying to figure out what the super user password is. And say they try 20 times, 30 times, 40 times, and eventually they get it. Now they have the super user password. But say they don't really want to use it right now. They want to come back later and gain access later. Maybe like later this week when they figure something else out. Okay, so they've got their way in, but there's going to be messages in var log messages that say failed super user access, failed super user access, failed super user access over and over and over again. And you as a system administrator will be able to see that and say, oh, somebody did that, I better change the super user password, because you'll see that they got in after 20 attempts or whatever. All right. But if they were really clever, what they would have done is they would have logged into the system, they would have tried to get the super user password over and over and over again, and then they got it eventually after 21 tries or whatever. Now what they would do if they were clever is they would go into var log messages and delete all those unsuccessful attempts, maybe even delete the successful one, okay? And then they would log out. And then they would have the super user password, and there would be no record on the system of them failing to get it. And so as a system administrator, you wouldn't be able to tell that they broke onto your system and got this message or got this information because they covered their tracks by deleting the log files. So what you can do on a networked system, all right, is you can log this information to some remote computer. So here I could use the @ sign like we use in email, like that sign down there. So I could say something like @Adams here. And then what it would do is it would log this information also to var log messages on the computer Adams. And then that person that broke into this computer would also have to then break into Adams to cover up their tracks, which is going to be a lot harder. They're going to have to go through the whole process, and maybe then Adams is going to log its attempts, failed attempts on some other computer or something like that. Or maybe Adams just only has like one account that even is used, and it's just typically, or it's just a dedicated logging machine. And we had those at an internet company that I worked at, very secure machines that didn't really even have any ways to log into it, and log messages went there, so we could always track down if somebody broke into our system. All right, so that's just a mechanism so that you can log messages to other computers, and it's a more secure way of keeping your log files. Now, another good trick to have in your bag for troubleshooting problems is to know the dmessage command. And the dmessage is what it does is it displays the kernel ring buffer. And the kernel ring buffer is basically just a list of recent kernel messages. So very important messages to your system, or these are the kernel messages. All right, and dmessage, if we hit enter here, a bunch of messages would come up on the screen, and a lot of those messages are already, written to other log files. A lot of them scroll by on your screen when you boot up your system, but dmessage just gives you a way to group them all together and see them all in one shot. right? The stuff that scrolls by on your screen when you boot up your system, you can't really read that stuff. Like even if you had a speed reading course or something, you can read it to the level of detail necessary to really troubleshoot some problem. So dmessage gives you a way to go back and look at those messages. And if I pipe this through more, you'll see the nature of what dmessage outputs, and what you'll probably gain right off the bat is that it's a very, very detailed listing. There's all sorts of information in here. It's telling me what speed my processor is. It thinks how much memory I have available. Information about my caches and how much space I have in my caches. Unbelievable amount of stuff is in here. And if we page down a little bit, here's some information on some drivers. So basically, the messages of in this dmessage output here are information on my system's hardware and the drivers. It tells me what devices the drivers are controlling, whether the drivers were brought up successfully, like here it says bus logic was initialized successfully, that kind of stuff. Okay, so this information is very, very crucial to diagnosing major problems in your system. So this process of troubleshooting a problem on your system has to do with, gathering information, right? We saw how we can look at log files to gather information about, events on our system and when they happened, what kind of things did happen, and so on, and try to put some kind of a timeline behind things and just try to fill in all the missing pieces. Okay, and so any of the system status tools that we've learned so far throughout this video series that can give you some information on that, by all means use them. Remember, for networking stuff, we learned the ifconfig command, and this ifconfig command, if we gave it a network interface, it would tell us all sorts of information about that network interface. The route command, remember, that displayed the IP routing table, and it told us some stuff about what our gateway was, what interface it used to travel to this particular destination, and so on. Okay, so these tools that we've learned before, I don't want to go over them all again in detail, but go back and brush up on those tools, because those tools are really your key to gaining information. The df command and the du command tell you all sorts of stuff about the usage of disk space on your system. There's the fscheck command for checking and repairing your file system, right? There's the lpq command for line printer stuff, so we can see what's in the queue, when it generated, when it started, right? Another very useful command is the top command. Now what top does is it displays information on processes that are running on your system. And now this is kind of like an interactive display, and you'll see it update. There it went. It updates every so often, every 5 or 10 seconds or something, and just displays what are the top resource hogs on your system. Okay, and you can see here the percentage of CPU time that they're using. You can see how much memory they're using, how long they've been running, what their priority is, what user generated them, what user started them up, that kind of stuff. Okay, and also over here on the left is the process identification number that you can use if you want to kill some process because it's hogging your system. So a lot of times, like, troubleshooting problems stem from some process runs out of control. Right? And that process that runs out of control all of a sudden eats up all the memory, and now things don't seem to work right. Well, it's not because, your memory cards have come out of your computer or the memory's bad. It's just because some process is out there eating it all up, and maybe it's got some, it just won't stop running. It's got some sort of an infinite loop in it or something that just makes it keep running and keep hogging more and more resources. And you can see here that actually top itself is one of the, it's one of the top hogs of memory and CPU time. Okay, so you don't want to just leave this running all the time, because it'll actually hog up some memory and CPU resources itself. And instead, use it if something's a problem, and then you can get all sorts of information up here, like how much time is being spent by users, how much by the system, how much memory is available, how much memory is used, your swap space. So it's a lot of commands sort of built into one. Okay, you get output from like the df command, you get output from like the ps command, the process status command, and so on. And you can really learn a lot about your system by looking at the top command. And like I said, if you need to kill some process because it's out of control, you quit out of top with a Q, and then what you can do is you could just like kill some process. Remember, use the -9 option to terminate it immediately, and then you could give the process identification number of the process that you want to kill. I don't want to kill any processes, so I'm not actually going to do that for you. Okay, so like I I said, any of these system status tools that we've learned so far, by all means, use all of those that you have in at your disposal, all of those that you remember and know how to use well. Use them to gain information about what's going on in your system and what could be the cause of the problem. All right, it's time for a joke. Okay, so 3 people get in a car, an electrical engineer, a chemical engineer, and a computer engineer. Okay, and the car doesn't start. And the electrical engineer says, well, I know all about electronics. I'll go out and fix the car. So he goes out and messes with the batteries and the wires, and the car still doesn't start. The chemical engineer says, well, it must be the fuel and the ratio of the fuel to the air and so on. So she goes out and tests the carburetor and does all this stuff. The car still doesn't start. So the computer engineer says, well, why don't we all just get out of the car, get back in, and try it again? Okay, so it's not a very good joke, but it illustrates a point that I know this has happened to you before, that you've been running some program or something, and all of a sudden, the program just doesn't seem to work anymore. It seems kind of stuck or something. And what you do is you close it and you open it back up again, and everything seems fine. All right? Well, the key here is that you've got to somehow deduce whether it's that program or it's some underlying cause that's causing that program to go bad. So remember over in the etc init.d directory, okay, there's all these scripts in here to stop, start, and restart processes on the system, like the sendmail process or the line printer daemon or zinetd or whatever. Okay, and there's all these scripts in there that stop, start, and restart those processes. So if you just need to get something running right away, it seems hung, then definitely the right thing to do is just to go ahead and use the script in here and say, say it's the sendmail script that seems hung today. Okay, and so you go in there and you do a restart on that script. And we've done this in the past, but I just wanted to show you again. So we say etc init.d sendmail, and we say restart, and there it goes. It says shutting down sendmail, starting sendmail, and everything. And if sendmail is working now after this, great. You did the right thing. You got sendmail running again, but you still haven't discovered the cause of the problem that made sendmail, go bad, get hung up or whatever. All right, and so keep notes of this. Keep track of this in your notebook and say, well, I had to restart sendmail today, blah, 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 and maybe try and take some notes on what else is going on in the system. And, if like, the next week, it seems kind of like the same problem, but it manifests itself in, the line printer daemon or something stops working, then, take note of that. And it's not the individual pieces like sendmail and LPD and whatever else goes bad. It's some underlying cause that you've got to get to, and the more notes that you take and the more diligent you are about recording information and gathering information when something does go wrong, you're going to be better off. But the good short-term solution is just to take that thing and stop it and then restart it. So if you're trying to kill or stop some process that doesn't have a script in this etc init.d directory, go ahead and use the kill command to kill it, and then just restart it manually by just running it from the command line. Okay? And that's the way that you deal with processes that don't have scripts in this directory. But what I want to get across here that's really important is you never, ever, ever want to use the kill command where you do have a script available to you. Okay, so if I went and instead of saying etc init.d sendmail stop, for instance, if instead of saying that I said kill followed by the process identification number of the sendmail program, well, by using the kill command, I'm not really stopping it gracefully, and I might not be able to restart that process by saying etc init.d sendmail start, for instance. All right, and the reason is there are these things out there called lock files, and these lock files control a lot of these programs. And basically what the lock file is doing is it's not letting sendmail start again because it thinks the old sendmail program is still running because the lock file is there. Okay, and that's a simplification, but that's basically what's happening. And so if you see error messages in your logs that say something about a lock file when you try and start sendmail, well, the reason is that this lock file is present. You need to go find where that lock file is. Maybe it's listed in the error message. Maybe you need to look it up in the man pages or on the web or something, and then look where that lock file is, get rid of it, and then try and start that process again. Okay, so these lock files can prevent you from restarting a process that's been killed incorrectly. Okay, if you just use the kill command instead of using the stop command. One last thing I want to talk about on this topic of stopping, starting, and restarting processes, and then we can wrap up here. Sometimes you track down a problem and it's a configuration file setting. Okay, so you need to change some system-wide configuration file, and you think that's going to solve this problem that you're troubleshooting. All right, so let's try and make this a little more concrete. So say you've got the zynetd.conf file here that controls the Zynet daemon, okay? And say you change something in this file, okay? So you make some change to this file, and now you want zynetd to reread this configuration file. Well, how do you do that? Well, one way that you can do it is just restart the zynetd daemon. Say etc init.d, zynetd, restart or something. All right, and that restarting, every time a process starts, every time one of those services starts, it reads its configuration file over again. All right, so that's one way to do it. But by doing a restart, you've interrupted service. So if somebody was using the zynetd service, then they get interrupted, they can't use it anymore, and then they've got to come back and do it all over again. All right, so a better solution is to do what we call a hup. All right, and if we look at, you do this by the kill command. Let's do a kill -L to see all the different kill options. And you'll see number one here is what's called a sig hup, and sometimes it's just called a hup. Okay, and what you do here is you say kill -1, and then you follow that by the process ID of the service that you want to hup. So in this case, the zynetd, if we look at that process identification number for the Zynet daemon, and it's like 1, 2, 3, 4 or whatever, then I would say kill -1, 1, 2, 3, 4, and what that would do is that would hup process 1, 2, 3, 4. And when process 1, 2, 3, 4 gets hupped, what it does is it rereads its configuration file. But it never stops, so service is never interrupted with a hup, whereas it is interrupted with a restart. And for certain things, like when I worked at an internet company and we needed to change some configuration setting on the web servers or whatever, we did that, but we definitely did not restart all the web servers. We just hupped them so they reread the configuration file because we didn't want to disrupt service. Okay, and we didn't want people to log on to our web page and say, well, geez, the web server's not up. This stinks, and then they don't come back anymore. Okay, so the point is, if you have some service that's critical that people are using, and you need that service to just reread its configuration file, you hup the service, and there's no interruption of service time. Well, it's time to wrap up our first nugget on troubleshooting. In this nugget, we tried to go over the types of problems that you might encounter while troubleshooting, whether they're hardware problems or software configuration problems, that kind of stuff. And we talked about the log files as being tools to gather some information. You can look at the log files and determine whether it's like, a mail error or a cron error or something like that, and that'll help you narrow down your focus as to what is causing the problems. And we talked about some tools that we really learned them before. I was just trying to refresh your memory of things like the ifconfig command, the fscheck command, things like that are tools that you can use to gather information that's not in log files, right? And that still is going to help you determine what the root of the problem is. And finally, we talked about stopping and starting processes as sort of a measure, a temporary measure to keep things running. Even if there is some problem present, a lot of times just stopping and restarting a process is a good way to, just to get it running in the immediate term. And long term, that might not be the best solution, but it helps you, just buys you some time while you're investigating. And lastly, we talked about the hup, which is really just some way to get a process to reread its configuration files. All right, well, I hope you found this nugget informative, and thanks for viewing.